Good morning, everyone. Myself Dharma. Today's subject is applied thermodynamics. My roll number is 20951 A0314. Today's topic is fuel consumption calculation. I am from mechanical branch. Abstract. The 5 driving test mode in vehicles, driving class cycles made by Environment Protection Association (EPA) in the United States of America (USA) to fulfill or reflect actual driving environments. Recently, fuel consumption value calculated from the adjusted fuel consumption formula has been more effective in reducing the difference from the experienced in a real world driving conditions. Then the official fuel efficiency equation used in the past that only considered the driving environment including FTP and HWFET vehicles. There are many factors that bring about divergence between official fuel consumption and that experienced by drivers, such as driving pattern behavior, accumulated mileage, driving environment, and traffic conditions. In this study, we focused on the factor of causing changing of fuel efficiency value calculated according to the how many environment conditions that appear on the real road are considered in producing the fuel consumption formula and that of the vehicle's accumulated mileage is in a 2.0 liters gasoline fueled vehicle. Introduction. In a vehicle, specific 5 cycle fuel efficiency used to derive a 5 correction formula and which known to assist the approximate real world fuel economy. Real world driving conditions have been well accounted for the fuel consumption. This can have been achieved by the considering the effects of driving environment shown in US 06 SC03 and cold FTP driving cycles. Invisible in FTP 75 and HWFET cycles on fuel consumption. Each of these newly introduced regulatory driving classes are characterized by the presence of frequent acceleration and deceleration regions. Driving in a vehicle with an air conditioner on and driving a vehicle in a cold environment. So, fuel consumption calculated from the process contributes to bridges diverges between real world and laboratory fuel consumptions. Late, related that the characteristics demonstrated in a condition driving class cycle US06, SC03 and cold FTP have a major effect on lowering fuel consumptions. Also, it was found that the presence of frequent acceleration and deceleration regions are the highest factors undermining fuel consumptions. Experiment description. In this study, the environment was performed with a 2.0 liters gasoline powered vehicle Hyundai Quiescent plant Korean, Korea, which is combusted by the premixed air fuel mixture. The test vehicle came equipped with an 16 value for cylinder engine. A multi-point fuel injection system is applied to the vehicle, implemented in such a way that the fuel is injection into the intake stroke with just upstroke of the each cylinder intake value. The cylinder value was operated with a continuous variable value timing technology CVVT, which improves fuel efficiency by changing the cam value profile developing on operating conditions and operating strategies instead of opening and closing intake and exhaust value with a fixed cam profile. Three regulatory driving cycles. Three regulatory driving cycles. The three regulatory driving cycles FTP 75 HWFET and US06, which were established by EPA Environment Protection Agency, were selected for measuring the vehicle emissions. These the three driving cycle modes shows the various situations that can occur on real roads. FTP 75 cycles the cycles are introduced in a simulate the urban way. Characteristics of cycles are described with the distance traveled 17 kilometers, the duration of 1873 and average speed is 34.1 kilometers per hour. As shown, the FTP mode can be separated into the three regions which different operating conditions. The first phase in the range from 0.250 is called as a cold start phase, since the engine does not close start until the FTP cycle is designed. It is relatively colder than it is the other passes. The cold start phases is followed by a second phase called the transition phase that plays the role of warming up the engine. A detailed analysis of US06 cycle. Since both city and highway mode characteristics and thus increase in the CO2 concentration levels as the vehicle's cumulative mileage increases were clearly demonstrated in US06 driving cycles. C02 and highway modes of US06 cycles into several regions wherein the vehicle is operated with acceleration and deceleration in the city mode and the only with the acceleration in the high mode. Figure 9 shows the velocity profile of city mode in the US06 driving cycle. The speed profile is largely divided into three regions in terms of the relative magnitude of load applied to the engine. The regions of A, B, C corresponded to the areas wherein middle, high, and low loaded are applied to the engine respectively. As mentioned previously, since the measurement of C02 concentration levels made during one driving cycle is largely affected by driving behavior, specifically through the instantaneously speed. All compressions of changes in C02 and C0 due to the again of the engine were made from test data that related the most similar velocity profile in the time domain corresponding to rapid acceleration and deceleration regions among test data tested according to the cumulative mileage of each vehicle. The regions of A, B, and C correspond to the areas wherein middle, high, and low loader are applied to the engine respectively. As mentioned previously, since the measurement of C02 concentration levels made during one driving cycle is largely affected by driving behavior, specifically through concentration through the instant speed. All comparisons of changes in C02 and C0 due to gaining of engines were made from test data that related the most similar velocity profile in the time domain corresponding to rapid coagulation and declaration regions among tested data tested according to cumulative mileage of vehicle. Thank you. Thank you for giving this wonderful opportunity to share my views. Thank you, and all.